Good day and welcome to today's video. So how do you solve a problem like this? We want to apply our knowledge of gamma functions to solve this problem. So we are given to solve the integral from 0 to infinity x cubed exponential minus 4x dx. So let's look at the solution together. So to solve this problem, you have, or let's say let I be integral from 0 to infinity x cubed exponential minus 4x dx. Okay, so if you recall, the gamma of n is defined by 0 to infinity x to the n minus 1 exponential minus x dx. Now I told you that whatever notation you use for this variable x, it doesn't matter. This can be t, this can be y, this can be anything you want whatsoever, as far as everything takes this sample of, it takes this format, this pattern of the gamma function. It's okay and we are good to go. Now if you compare this with this, you will discover that on this the expression is almost the same. The boundaries of the integral 0 to infinity, we have x to the something on this one, and we also have x to the something on this one. But the problem is here. This place I have 4x and this place I have x. So the definition of gamma function is supposed to take only this variable here and nothing else. So to solve this integral, so I'm going to make a substitution. So I'm going to introduce one of my favorite variables, t, and I'll say let t be what? Negative 4x. Sorry about that, not negative. T should be 4x. So we just want to replace this one so that at least the new function we will get will look something like this. Okay, so if t is 4x, then dt is actually what? 4 dx. Is that okay? dt is 4 dx because if you differentiate 4x, you get 1, and since you're differentiating t with respect to x, this is what you get. dt is 4 dx. In other words, dx is 1 over 4 dt. Is that okay? Now that you have made these crucial calculations, you've substituted 4x for t, and you have changed the x to 1 over 4 dt. You also need to check the impact of this substitution on your boundary. So we have t is equal to 4x. So when x is equal to 0 at this point, what is t? T is equal to 4x, 4 times 0, which is 0. And when x is equal to infinity on the upper side, t will be 4 times infinity, which is still infinity. So as we've made the substitution, okay, our integral will still remain bounded between 0 and infinity. We've made the substitution transforming our integral from the x domain to the t domain. So x, if you want to find the value of x, you just make x the subject of the formula here. So x here will be what? T over 4. So in place of x, I'm going to call this t over 4 cubed. Are we good? Then I have exponential minus 4x being minus t. So dx is 1 over 4 dt. Okay, so we have transformed our integral to this form. So I is 0 to infinity. So you have t cubed all over 4 raised to the power of 3. Are we good? And we now have exponential minus t. Then we now have 1 over 4 dt. So if we remove all the constants, I'll have 1 all over 4 raised to the power of, according to law of indices, this is 3 plus 1, which is 4. Then I have integral from 0 to infinity t cubed exponential minus t dt. So if I have this integral in this form, I is 1 all over 4 to the 4th power, and we now have the integral from 0 to infinity. So I can actually see that this one looks more like my definition of a gamma of n. For instance, gamma of n in terms of t is 0 to infinity, and I have t to the n minus 1, then exponential minus t dt. So this is one way of representing your gamma function. So you just need to look for how to change this 3 to something like n minus 1. So this is what I'll do: 1 all over 4 raised to the power of 4, 0 to infinity. So t 3 is still the same thing as 4 minus 1, then exponential minus t dt. So you all agree with me that this becomes the gamma of, remember, gamma of n is n minus 1, okay? Then that's in the bracket side. So this becomes my n. So this is gamma of 4. Are we all together? So gamma of 4. Yes, good. So I hope you all understood how I got it. So gamma of n is t to the n minus 1 exponential minus t dt, meaning that gamma of t raised to the power of 3 is still gamma of 4 minus 1 then exponential minus t dt. So if you compare this with this, you discover that n is 4, and that is why I have 1 over 4 times gamma of 4 in this integral. And since we have learned how to evaluate the gamma of whole numbers, gamma of 4 is 3 factorial. So you have 1 over 4 raised to the power of 4 times 3 factorial. So we have 3 factorial over 4. So this is what 3 factorial is 3 times 2 divided by 4 raised to the power of 4 is 256. So whatever it gives me, 3 all over 128 should be the final answer for my I. So you can verify this by yourself. Well, let me just be sure. Gamma of 4 is 3 factorial. Okay, so 4 raised to the power of 4. I hope I've not forgotten 4 raised to the power of 4. Okay, 256. Good. So this is it. 3 factorial is 3 times 2 times 1, if you please, but I normally leave it as 3 times 2. So this is it, guys. The answer for this integration is going to be 3 over 128. Is that okay? So thank you for watching this problem. Please like, subscribe, and hit the notification button to stay updated in case you've not subscribed. Please, I'm emphasizing that you need to like my videos if you want it to fly, and if you want other people to know what you've known from these videos, share to your friends and to your colleagues, and tell them that there is a blessed that teaches engineering mathematics very well. So I hope you understand, and I hope you will be confident enough to solve any problem that comes your way. So if you have any question or any comments, please leave them in the comment section, and in the next class we are going to start with beta functions, and I can't wait. So see you then. Bye.